Hello everyone! In this video I want to provide you some methods in order to define your different parts with the PDM data and mostly PDM Mesh Flag and optionally PDM material when you are dealing with a part buzzer workflow. As a first reminder, please keep in mind that this PDM MID, PDM material, PDM Mesh Flag, they can be inherited from either the PLM system or the CAD directly. Let's say that I want to open recent this tape, for instance. Let me say don't save, and into this tape pop-up you can see that you have the PDM attributes where you can map the data coming from the CAD to these PDM attributes. But for the moment, this model is completely free of PDM attributes. So let's see how we can populate them shortly. Let's have a look at different methods, starting with the first one, which is to make sure that all your parts are instanced together. So here you see that there are multiple parts with this small infinite symbol at the bottom, which means we have some instance in the model. The quickest way to retrieve a hierarchy with all the instances is to go to Assembly, Match. I will select here all my parts, leave everything empty, and just click on Match. This will open a pop-up, or this will split this browser, into two different windows, and the left-hand side windows will contain all the different instances one by one. So let me isolate the first one, right-click, isolate only, and just for the sake of explaining my strategy, just let me show the second one. So you see here that we have screws and bolts, and in our FE model, a pair of screw and a bolt will consist into a fastener. So we don't want to keep in the session both entities, the screw and the bolt. So for the bolt, we will decide to assign, so let me go on screen, Control A, right click. I need to leave the match part, go to part again, idle mode, Control A for everything which is on screen, right click, edit these parts, and set PDM Mesh Flag to none. Close. Now let me reverse the view and use this icon at the bottom, which is the lock and view, and which means if I escape anything and now I say A for showing all my parts, the bolts are not shown anymore because the view has been locked and the bolts were not there. So doing this, I can iterate on the part where I have the main instances of the main number of instances. So let me isolate only this one, for instance, Control A, and let's say that it will be PDM Mesh Flag. Connector, I could say connector, or as it is a free field, I can even say, okay, this one, I really want them to be fastener. And then let me leave the fastener. Again, let me reverse the view, unlock, lock again. And this way I'm getting rid of these screws and etc, etc. So first step, you see as I'm doing, I got instance, this one on screen, Control A. I will leave it at PDM Mesh Flag XR. So strategy number one, we use the instances to process parts which are repeated multiple times in your model. So again, reverse, unlock, lock the model, and etc, etc. Another way or another method to work with the model is to look at specific string pattern, specific names. So here I think I had some, so let me try to see some of the parts which are remaining. I have this part which is 111. This one is 147, so I guess it is linked to the lens. I wanted to check. Yeah, there are 111 here, and this one, if you remind, it was 111 too. So strategy number 2 is about the name. So here we could say, for instance, that we want all part IDs starting with 111. And it could be question mark because there could be, I think 111 should work. Enter. So you see that I have a couple of them appearing. Now let me say Control A, sorry, from the part browser, Control A. And from this one, let's say that I want to change the PDM Mesh Flag and say again, this would be a fastener. Okay, 3. So why is it failing? Because I selected too much entities. So Control A, I need to be on one part, and Control A, you see that the part has not to be defined. The part sets, the part assembly, sorry. And here I can do fastener again. And this time it should have been defined. Here it is, fastener. So I can select again, Control A my part, hide them, and do again the show and show. So strategy number 2 was about the part name. There's still a couple of parts. I want to get rid of small parts before getting to the next step. So let me pause, and once I've cleaned the remaining screws and some bolts, I will continue with strategy number 3. So let me unlock my model to reverse. Control Z, escape, reverse. So this is everything that I saved as instance right now, so not a lot of extra parts. Let me reverse again, lock. And let's have a look at the third method. In order to do it, this method being based on geometric attributes. So if I look at my different parts, there are some parts for which it is pretty clear which mesh I want to get. So for instance, for this part or this part, I want tetra mesh. Same for the battery case at the bottom. And for this plate, I want to demesh. So which criteria can I use in order to distinguish them? Let me open the matrix browser to show you how we can, for this case, use the volume to achieve this goal. So let me go to HM, I will go to solids, I will query, and first let me take the solids that I want to tetra mesh. So let me take a couple of solids here, and I will include this one too, validate. And for this solid, I want to query their volume. And you see the volume is between 800 and something like 15,000. Now let me do the same with solids that I want to 2D mesh. So let me take different, let me try to find the largest one for 2D mesh. This one is quite large, 1, 2. This one I could try. And then the opposite, let me take one small in order to see how it goes for the small ones. And let me go to volume, query, and you see that the volume is between, or is getting up to 5,000, but that's all. The one thing that I could do in order to sort out the parts which are with a low volume or with a larger volume is to do some TCL lines in order to distinguish both. So let me show you how you can do it using the same attributes than here. First, there's a couple of parts that I would like to hide. This cylindrical one, I guess they were hidden in the past. So first let me switch to the complete view, to the one single view. Let me check for the PDM Mesh Flag in one part. PDM Mesh Flag, make it as a column, and let's say that I want the one with PDM Mesh Flag exa. Some typo here. And Control A, and I will hide them. Okay, let me unlock and lock. So now let me go to View, TCL console, TCL command window. From 2023 to increase the size, you can just scroll up and scroll down. So let's say that I want to select only the parts which are greater than 5,000. Start create mark. So it's solids. I am dealing with solids. One greater than, or the one, the buffer one, I will say displayed. So I'm selecting all the solids on screen. Then I'm creating a second selection, create mark solids 2, greater than or equal to value 5,000. Equal to value and double quote what attribute the volume, which value 5,000. So 18 solids. And now what I want is star mark intersection. So I'm taking the intersection of both solids 1, solids 2, and the intersection will be pushed to buffer ID 1. And to complete mark to user mark solids 1. So this mark to user mark, now that I've used it, I can go to solids, right click anywhere, select retrieve selection, and for this one, and I will select a couple of extra ones here, these two ones, and these two ones, and I will say right click, edit these 22 solids. Oh, sorry. Let me isolate them instead because I need to turn it into parts. And let me select these parts, edit 22 parts. PDM Mesh Flag will be 3D mesh. Enter, close, reverse. So this is what is remaining to me. So I could continue to sort out what is 2D and what is the couple of 3D parts still, but then majority will be 2D. So this is basically how you can do it by hand if you're not using any learning method. So now that we've seen these three basic methods, let me change the model and show you another approach which requires more preparation, but which is worth on the long term. So the fourth method, and which is probably the smartest one at the long term, relies on a feature that was introduced in 22.3, which is called classify. We have this match capability which allows to find the same instances, so finding the similar parts, exactly the same shape. The classifies allows us to get a step further and to gather parts together based on also different shape considerations, let's say. So what is the purpose of classify? We will learn, or we will create a model, and we will provide inputs to this model coming from different models, and then we will make this model learn how to classify the parts that we can reuse it later on new models. So let's start by defining labels. So let me create a new classifier. It will be a new learning method, a new learning algorithm. So automotive parts, let's say. Okay, and I will create 3 labels to start with for this model. So one with all the casting parts, and for the sake of this demonstration, and by the way, you can retrieve this demonstration within the online help. It's part of tutorial. So once you're in tutorial, you will be able to repeat the same step that I'm doing right now. So here I will select the part by part set, and the model was already built in such a way that the parts are already sorted in 3 different groups. Once you have selected the parts, you can hit on the plus, and the castings will be of the parts which were defined or which were already previously stored in this part set will be pushed to the casting label. I can create a new labels for the panels, for instance. Okay. Again, part sets coming from panels. Let me hit on plus, and you will see that here again the color will change. And finally, I will create a new one, which is extrusions. And I will select parts, extrusions, okay, and I will hit on plus. And I can already start to train my model. To be able to train your model, you need for each label to have at least 3 different parts. So here I can run the first training. And once the training will be completed, we will have here a matrix, a confusion 1 matrix with the quality, the precision for all the labels. Now let me load a second model, and let me go to classify again. I want to go to label again, extrusions parts. I can go to again these parts. This model was prepared so that the parts of interest have been stored into specific part sets. Part sets are hypermesh internal entities, are not pushed to solver. So you can define them on the fly. Let me go to castings, same castings. Let me go to panels. Panels, okay, plus. And here it is, and I will go to train again and train the model. Obviously, as we're speaking about AI algorithm, we need data to get an accurate model, but for the sake of presentation, I use 2 models to start with, and let me load a third different model, which is another pickup. And what we're aiming to do is, as soon as you will get a precise model with all data, what you can do is to go to classify for a new model. You will say that you want to work with automotive parts, and you see that each time you make the model learn again, it increments, so I generally pick the latest. And here you can select your parts. So take all the model and run classify. So here the learning model will try to split the different parts or between casting, extrusion, and panels. Some of them won't fit in any of these classification. And the point is, as soon as your model is trained and that you have, for instance, castings, extrusion, or panels, you should be able to say that, for instance, the castings, you want them to have a specific PDM flag, and extrusions could have another PDM mesh flag, and panels could have another PDM mesh flag, etc., etc. So here's the idea of using the classify in order to train hypermesh to recognize your different parts. Please note that it is recommended to identify or to work with high-level part hierarchy, working with panels, casting, extrusions, rather than trying to go too much into details, doors, window, etc., etc. So you may need to work a little bit on your model in order to increase the accuracy. But again, the larger number of data you will provide to your model, the more precise your model will be. So here's for the final strategy. Hope this helps you have a better vision of what we can do in the future with HyperMesh. See you later for another video. Goodbye.